One way to look at angle has to do with its degree rotation between the two rays that form that angle. And these two sides, this initial side, which is usually, and you guys will talk more about this in trig, initial side and this terminal side, just the starting point and ending point. Right? And the angle is simply the rotation from that. So from this ray to this second ray, again, they're both two rays, each of them is a ray, is your degree of rotation. If you're thinking of an angle in terms of rotation, you're probably using its measures. And so the question kind of came up, do you need your measuring tools yet? No, you don't quite yet. Chapter 2 has the measuring tools on them, but this is a protractor. Most protractors have some kind of crosshair at the very middle of it. And if you place that crosshair on the intersection of your initial and terminal sides, and then you align the bottom to one of those sides, you'll be able to identify what the measure is. So if we look here, we either go from 180 up to 140 or 0 to 40. We're not working backwards, so we're looking at this rotation. It's a rotation of 40 degrees would be our angle measure if we're looking at that. Okay. Now you can also think of an angle as a degree of straightness. If you're looking at that, and this was kind of more historically how it was looked at, because they didn't actually measure angles. They just looked to see how does this relate to a straight line. And we'll classify this, but degree of straightness would be the other way that an angle, or the inclination of two rays in an angle, how do they relate to straightness? Okay. As far as the anatomy of an angle is concerned, an angle has one common point between the two sides called the vertex. The initial and terminal sides are usually just referred to as sides. And then with respect to an angle, points are either going to fall in the interior of that angle. Points might fall in the exterior of the angle. Or points might fall directly on the line or on the angle itself. So the vertex is one example, but here points A, B, and C lie on the angle. Okay. So it's either in the interior, exterior, or on an angle as far as how points might be situated. Okay, when you name an angle, there are several different naming conventions. The first and easiest one that applies to all types of angles is to just use 3 letters. So the 3 letters are the number of points the minimal number of points to actually determine that angle. Okay, so to determine this initial side, you need the vertex and a point that's on the ray. To look at the terminal side, you need the vertex and another point that's on that ray. Since the vertex is shared between them, you simply need 3 points to name an angle. And when you name it, you'll use an angle symbol. And then the 3 points, the order of the points don't matter as long as the vertex is the middle point. So angle ABC or angle CBA are acceptable ways to name that angle. Okay. Now, if the vertex is unique to a single angle, so if this point B is a vertex of this angle and this angle alone, angle ABC, you could also name this angle by the vertex itself. So we could just call this angle B. And then the final way that we could name this is if you put a number in the interior of that angle, we could call that angle 1 as well. So you can number your angles if you needed to. Those are the 3 different ways that you can name an angle. Now, it's not all the time that these outside forms can be used to name an angle. Casey, question?
Should it always go that way, the angle sign?
Yeah, the angle should always, even if your angle's opening the other way, have it open to the right, like that. David?
So the number doesn't have to be in there initially. You can put the number in there?
Yeah, anytime you want to label something, you can add a number to it just to make it easier to refer to. Yeah.
Same with a line or a plane or a space.
Like if you're putting like a capital letter to name it, you can add those. Yeah, you can always use naming conventions to help make it simplified for you. Definitely. Okay, let's take a look at a case where these outside methods may not work. If I gave you an angle with another point in its interior that forms multiple angles. So now here it's not just 2 angles that are formed, because you have these 2 interior angles here, but you also have this larger overall angle. Okay, so if you're naming these using 3 points, okay, you can name every single one of them. So we have angle WXY, which can also be named the other opposite order, YXW. We have this angle down here below, which is angle YXZ or ZXY. Again, the order doesn't matter. And then we also have the whole larger angle WXZ or ZXW. And so those are the 3 different angles that you can find in here. And now, if I were to try to name this using just the vertex angle X, which angle would I be referring to? Do you even know? No, because you can't distinguish it with just this. It's a more efficient way to name an angle, just takes less effort. But if it doesn't distinguish it, you cannot use it. So don't use an angle X for these. However, like David asked, can you put your own numbers in there? Yes. If we put number 2 and 3 in here, we could have also referred to this angle here, WXY, as angle 2. We could have also referred to this angle YXZ as angle 3. So we could simplify it. However, can we name this larger outer angle with a number? No, because again, it's not going to be a useful way to try to label this whole thing and indicate that it's all represented by one letter or one number. Just use the 3 points on it, and that's the acceptable form. Jacob?